So let's go ahead and get started. First one, is this a function? Yes or no? What do you guys think? Throw it in the chat. Yes or no? Go with your gut. Guillermo says yes. Throw it in the chat. You can do it public, you can do it private. Ajira agrees. Is this a function or is it not a function? You have 5 seconds to respond. Say it in the chat. 5, 4, 3, 2, 1. Okay, I see a lot of yeses, and yes, it is. This is a function. Now, the reason is also important. You have to be able to explain why it is. The reason it is a function is because every input has exactly one output. And we will talk about that today. So again, anything you don't understand, we'll review. But just so you're aware, that is the correct answer. Example or letter B, what is the x-intercept, y-intercept maximum? This should feel pretty good because we just did all this. So shout it out, put it in the chat. X-intercept, good, 5.5. Y-intercept, 48, good. And the maximum, I saw Guillermo. Good, 146, that looks about right. It's a little bit more than 144. So 146 is a pretty good guess. Okay, so again, example B, we've done this pretty recently, so hopefully we don't have too many questions about that. Here's my maximum, y-intercept, x-intercept. All right, what is f of 4? This one might be a little more challenging, but let's see who gets this one. What is f of 4? I know at least 1 or 2 people know this one because they sent me the answer already. What is f of 4? Okay, Ajira says f of 4 is the output, which would be, Lauren, you got it. Now, what would be the number? What would be the answer? If I ask you, what is f of 4? You have to give me a number. We have to find where 4 is equal to the output, kind of. You have to find where 4 is, if 4 is the input, what is the output? Now give me a number though. 112, there we go. F of 4 equals 112. Now why? That's because 4 is the input, which is the x value. So on the x-axis, I go to my 4, here it is, and then I look up to where I am on the graph. This is 4, 112. So if 4 is my input value, 112 is my output. So f of 4 equals 112. That's function notation. Again, we will review that. Oh, somebody said that they had it in their mind, but they were too scared to say it. Never be afraid, guys. Send it in the chat privately. I will never reveal who you are. I promise that. I will never reveal who you are. Even if you get it right or wrong, I'm not going to reveal it. Okay. D, during which interval is the graph decreasing? Anyone think they got that one? During which interval is the graph decreasing? Ooh, Lauren, I think Lauren's the one who's got it. Yes. So when is the graph decreasing? That would be from the maximum to the x-intercept. This portion of the graph is the portion where it's decreasing. But in order to answer the question, you have to look at the x values. So 2.5 to 5.5. From 2.5 to 5.5, the graph is decreasing. And we write that using an inequality. So it's going to be 2.5 is less than x is less than 5.5. Again, we will review it. So don't worry if it's something that you're not understanding yet. Okay, now we get to the hard ones. This is what people usually struggle the most with. Domain and range. Anyone want to give it a try? Some of you might have it in there somewhere. It's kind of related to intervals. It's kind of similar. So there's going to be two answers. So one answer is the domain, and then the other one would be the range.
The input and the output.
It has to do with inputs and outputs, yes. So here, domain is input values, range is output values. So Guillermo, 5.5 wouldn't be the range because that's the X values. It would be the domain. So now let's think about this. 5.5 is like the highest number you can go. What would be the lowest number you can go on the X-axis? Good, 0. So basically this graph goes from 0 to 5.5. It doesn't go into the negatives. It doesn't go into the negatives here either. So it starts at the 0 and it ends at the 5.5. So the domain would be 0 less than X less than 5.5. 0, or the domain basically is just asking you what are all the possible X values on this graph. Same thing with range, except that range is Y values. So what's the lowest that this graph goes? 16. 16 is here, but it keeps going. It goes all the way down to 0, right? At the very end, it finally touches the 0. What's the highest that this graph goes? Not the numbers here, the actual function. What's the highest it possibly can go? It goes higher than that. There you go, 146. The maximum is the highest that it goes. And down here at the bottom, that's the lowest that it goes. So the range would be 0 is less than Y is less than 146. So domain, the lowest to the highest X value, and range is the lowest to the highest Y value. Again, we will review it, but are there any quick questions on that right now? Okay. Yes, quick question? That's not related to this. Okay, I should have been more clear. Last one. What is the average rate of change from X equals 1 to X equals 2? So this is something that definitely we need to make sure we know. From X equals 1 to X equals 2, let me see, what color have I not used? I'll use pink. X equals 1 is right here. So on my graph, I go over here. This is 1, 112. X equals 2 is over here. When I go up on my graph, I'm at 2, 144. Okay, run, rise over run, yes. So average rate of change, we know we're looking for rise over run, or you can use the very famous formula that maybe you forgot, but now we're gonna remember. M equals Y2 minus Y1 over X2 minus X1. And all you gotta do is you gotta take those two numbers and plug everything in. So here's my first point. Here's my second point. I go to my second point and I'm plugging in the Y value. So Y2 would be 144. Y1 would be 112. X2 would be 2. X1 would be 1. I do my math. 144 minus 112. Anyone? $32, good. 32 over 2 minus 1 is 1. So 32 is my rate of change. That would be my final answer. So again, we will review this, but in the meantime, make sure that you have this rate of change formula. I know it's somewhere in the back of your heads, so make sure you also have it down in your notebooks because we will be using that today. So this bell ringer, like I said, is covering everything that we're going to talk about today. So if there's any one of these that right now you're not so sure about, I want you to write it down in your notebook. Just write, okay, I need to review domain and range, or write that you need to review function notation. Just make a little note for yourself so that you know when to pay the most attention as we go through class. I'll give you guys a couple seconds to do that. Here's a question. How do you remember the equation after all these years? How do you memorize these things? The answer to that is you got to write it down every single time that you do it. Because if you write it, let's say you do it 3 times during class and then you do it 3 times during homework, if you write it down every single time, your brain is going to connect to your hand is going to remember how to do it, and then your brain is going to remember how to do it. So you just have to remember to write it all down, because I promise you, when you write down, you memorize much more easily. So let's go ahead and get started. So starting with, what is a function? What is a function? Can I have a volunteer, please, to read the definition of a function? Who can read for us this morning?
I'll read.
Go ahead.
A function is a type of relation in which there is only one output value for each input value. For every input value, there's a unique output value.
Exactly. So that's the official definition of a function. And you might see a question on your EOC that's just asking what is the definition of a function. So it's important to remember what the definition is. It's a relation in which there's only one output value for each input value. So what does that mean? That means that every x value can only go to one unique y value. So if there's any y values that are repeating, then you know that you do not have a function. So let's take a look. For example, the way that you figure this out on the table is to see if there's any repeating numbers in the y column. So in example A, are there any repeating numbers? Yeah, which one? Okay, but remember, we're looking only over here, only down the column. There we go, -2. Repeats. Okay, since -2 repeats, that might be an issue. Let's keep going. Repeating numbers. No repetition anywhere? That might be a good sign. Oh wait, hold on, I forgot to circle the -5 over here. There we go. Okay. How about here? Repetition. A lot of 4s, yeah. -3 repeat. Wow, we're repeating all over the place. That's a problem. How about D? All these 2s, yeah. So basically on a table, what you're always going to be looking for is repetition. Anytime that you see the same number going down the column, that might be an issue. But let's think about, I think I misspoke. I said only y, but let's actually remind ourselves what this means. The definition is every x value only goes to one unique y value. So for example, in example D, what's going on here is that the 2, how many different numbers does the 2 go to? This 2 goes to -1, this 2 goes to -2, this 2 goes to -3, this 2 goes to -4. So in the end, it ends up going to 4 different y values. But remember, it can only go to 1 unique y value. So since I have all these -2s and they're all going to different places, this is not a function. It has to be, yeah, so I think I misspoke before. We have repeating x values. That's what we don't want. Okay. 1, yes. So it can only go to 1 output. Same thing here. I have -3 going to -4, and then I have -3 going to +4. I have 1 going to +4, and I have 1 going to -4. In other words, I have repeating x values. So long story short, I did say the wrong thing before, so let me make sure we get this clear. Karina, because I said it wrong before. What matters is the x values. So look at the x values and make sure that there's no repetition. Okay, so over here, repeating x values, not a function. And same thing with A, we have repeating x values. So this is also not a function. So the only one that works is answer choice B. Okay, we don't want any repeating input values. No repeating inputs. Questions on this one? Will it be on the test? Yeah, this can definitely, everything that we are going to look at in the next month is fair game. So I don't know what the test actually looks like, but we have to prepare ourselves for every possibility. Questions on this problem? This is topic 2, technically. Okay. Now, what about a graph? Same exact definition. Now we're looking at graphs. And on a graph, there's one trick for how to identify a function. Does anyone remember what it's called? It's a test we can do. And that's okay. Yeah, no, be honest. If you don't remember it, don't remember it. That's fine.
A vertical test?
Mm-hmm. The vertical line test. The vertical line test is very simple. All you have to do is, if you draw a vertical line, you have to see how many times it touches the graph, the function, if it's a function or not. So let me be clear. So for example, in example A, if I draw a vertical line right here, how many times is it touching the graph, the relation? 3 times. 1, 2, 3. That is bad news, because if it's a function, it can only touch 1 time. If it touches more than once, it's not a function. So this would not be a function. How about B? Is there any place where it would touch it more than once? Yeah, Guillermo's correct. No matter where you go, if I draw a vertical line, it's only going to touch the graph 1 time. So for example, if I go over here, 1 time. If I go over here, 1 time. If I go over here, 1 time. All right, so it only ever touches 1 time, which means it's totally good. Graph B is a function. Okay, how about C? Is there any place where it touches more than once? Good, at x equals 8, if I draw a vertical line, what happens? It passes through 2 points. not a function. So even though in a graph C is very simple because, or very good example, because I could go like this. Oh, one time, oh, one time, one time. And you might think, well, each of these only touched one time, so it's fine, right? But no, if it happens even just once that it touches twice, it's automatically out. So even though this one's good, this one's good, this one's good, this one's good, and this one's good, since it's bad over here, it completely ruins the whole thing. Questions on the vertical line test. Another way that people like to think about it, and this might be helpful, is functions can't be on top of themselves. Okay, so for example, in example A, right here, this function is kind of folding on top of itself. See how it's stacking up on top of itself? So functions cannot stack on top of themselves, which means that for that reason, A is out, as well as C, because over here it's stacked up on top of itself. But graph B, it goes up and down and up and down and up and down and up and down, and it never ever stacks up on top of itself. So that's another way to think about it. Any other questions on this one? Okay, cool. So on a table, cool, good. On a graph, we're good. How about one of these, mapping diagrams? So mapping diagrams are just another way to show functions or to show relations. And then we can figure out which one is a function and which one is not. Now remember what I said, every input value has one unique output value. So every X value can only go to one Y value. So which of these is not a function? Good. Diagram B. What happens in diagram B? What happens? What's bad about it? Good, Karina. The 5 is going to 2 different outputs. 5 is going to 2 and 4. 11 is going to 6 and 8. So that's bad. Now, on the other hand, this might look kind of fishy, but remember, it goes one direction. The X can only go to one Y. How many Y values does the 1 go to? 1. How many Y values does the 2 go to? 1. How many Y values does the 3 go to? 1. The 4, 1, and the 5, 1. So even though 1 and 2 are going to the same value, that's okay, because all that matters is that the 1 is only going to one place and the 2 is only going to one place. So this is okay. That's okay. So basically, you can converge on the same number, but you can't branch out to 2 different numbers. Now, there's one more thing that sometimes they do, so I just want to make sure I cover this. What if, let me fix this a little bit. Okay. What if I had one more number here, but it wasn't going anywhere? Would that be a function? I have a 6 and it doesn't go anywhere. Is that still a function? So Lauren says no. One output value for each input value. This one's tricky. I'm giving y'all a trick question. Yes, no. So the answer is this would not be a function anymore. Because like Lauren just said, it needs to have an output. Look what it says, every input value, there is a unique output value. There has to be one. Since this 6 is not going anywhere, does this have an output value? No. But what's the definition? One output value for each input value. So it has to have one. If it doesn't have any, it's not a function anymore. So that's the kind of tricky thing, okay? So if you ever see a number that's not going anywhere, it's out. Even if everything else is fine, then it would no longer be a function. But if I go back to how we had it, then we're good. Any questions on this? Okay. Moving right along. Lastly, you might see a relation as a bunch of coordinate points. Now, when you have a coordinate point, the first number, is that your input or is that your output? Good, that's the input. So there's two ways to do this. You can just look at it and find any of them where you have repeating input values, or you can put it in a diagram. So if I'm looking at example A, I have 2 going to 7. Then I have 4 going to 13. Then I have 6 going to 19. And then I have 8 going to 25. And when it's in a diagram, it's a little bit easier to notice what's going on. So for A, are there any places where the input branches out? No. So this one is a function. And we're looking for the one that's not a function. So far, this one's not the one. And that's a really good way to do it, because when you can visualize it, it might be a lot more helpful. Oops. For B, five going to 2, 7 going to 2, 9 going to 2, and 11 going to 2. So they're all going to the same place. However, remember the definition. How many output values does the 5 go to? 1. 7 goes to 1. The 9 goes to 1. And the 11 goes to 1. So is this a function, yes or no? Yes, this is a function. Because there's no branching. They all go to the same place, and that's okay. As long as there's no branching, you're good. So that is a function. So that's where it gets a little tricky. Does anyone have any questions on this one, on B? Okay. And finally, well, not finally, but let's look at C now. Okay, 3 goes to 1. 3 goes to 4. 3 goes to 9. 3 goes to 16. Is this one a function? No. Good. So that's the big difference. You can totally converge. You can converge to the same number, but you cannot branch out. So this is bad, which means C is the correct answer. So branching out, not a function. Converging in, good to go. Questions on this one? All right. So that basically covers what a function is and what a function is not. Now, let's talk about a lot of different features of a function. And importantly, we're going to just make sure we understand function notation, which we'll get to over here. But let's start with domain and range, because that's always kind of the trickiest thing that people really need to understand. So remember that domain is all the possible inputs. So when I have a graph, what you always want to do is look at your x-axis and figure out what's the least or what's the smallest possible number on the x-axis and what is the biggest possible number on the x-axis. So what's our smallest? Good. See, Lauren's got both of them. We start at the 0 and then we end at the 6. And when you're going on this graph, does it skip any steps, or does it go straight up from 0 all the way to 6 without stopping? So does it skip any numbers? Are there any gaps in this graph? No gaps. Since there's no gaps, we can make it into an inequality. So our domain would be from 0 less than x less than 6. Now, another way that gaps are cubic, no, a gap would be like, let me show you an example of a gap. One example would be like if it was like this. Just a bunch of dots without connecting them. So this would be full of gaps, right? Because there's no line that connects everything. Another example of a gap would be if it was like this, but then maybe there's like a hole in the middle somewhere. You would see a literal hole in the middle of your graph. So those would be gaps. Now in this case, there's no gaps. There's one continuous line connecting everything. Okay, that's the difference. So since there's no gaps, there's no holes, it goes from 0 all the way to 6. There's another way to answer this. So you can say 0 is less than 6 is less than x, or you can say all real numbers from 0 to 6. You might see it written one way, you might see it written the other way, but just be aware that that's what it means. All real numbers from 0 to 6 just means that you're covering every single number between 0 and 6. Every whole number, every decimal, everything from 0 to 6. Questions on that one? Cool. And then range, similarly, this time we're just looking at the output values. So if I look at my graph, what is the lowest I can go? And then what is the highest I can go? Zero to 20, exactly. This graph goes down to the floor and that's it. It doesn't go lower than 0. So from 0 all the way up to 20. Right? From 0 up to 20 and then back down to 0. So exactly, Ajara. So the range would be 0 less than y less than 20. Or you can say all real numbers from 0 to 20. Why do we use less than symbols as opposed to less than or equal to? So less than symbols, the reason we use less than is because y is between 0 and 20. So y is going to be greater than 0, but less than 20. And if you read it that way, look at y in the middle. y would be greater than 0. But on the other hand, it's less than 20. And the reason we don't use less than or equal to, that's kind of a trickier question to answer, but the reason would be because this is a model rocket, right? So a model rocket is moving at all times. It doesn't stop until it reaches the ground, right? So you can't say that it's equal to because it's never going to stop in a specific location. It always keeps going. So it's kind of a weird reason. I wouldn't worry too much about it. Just remember that instead of using less than or equal to, we just use less than. Any other questions on domain or range? Okay. What is f of 5? Look on your graph. If you know it, send it in. What is f of 5? 10. Good. All you do, you go to the 5. 5 is your input. So you go to the 5 on the x-axis and you go up and figure out where you are. You're at 5, 10. So f of 5 equals 10. Now, if you didn't know C, try D. Try it on your own now. What is f of 1? Eight. It's a little more than 8. Look again. It's also 10, yeah. F of 1, I go to my 1 and I look and boom, there I am. I'm at 1, 10. So when the input is 1, the output is 10. F of 5 equals 10. F of 1 also equals 10. Questions on those two? This is function notation right here. Okay. Now, on the other hand, now this is asking for which values of x is f of x equal to 20. So is 20 my input value or is 20 my output value? Would that be the input or would that be the output? Anyone? Would 20 be my input or would 20 be my output? Good, it would be my output. So they're giving me the output and they're asking me, what's the input? Yeah, so this is backwards. So now I go to my graph. This time I'm going to the 20 and I look, and where am I? 3, 20. So that would mean that x equals 3. So you have to make sure that when you see a question using function notation, you read it carefully. If the number's in the parentheses, it's the input. If the number's out of the parentheses, it's the output. Input, output. Questions on D, C, D, or E? Okay, cool. Last one. During which interval is this graph decreasing? So interval means we're looking for x values. From 1 to 1, is it decreasing? From 3 to 6. You have to remember that we're looking for x values. So from the 3 to the 6 on the x-axis, it is decreasing. So I write 3 less than x less than 6. From 3 to 6, it's decreasing. From 0 to 3, it would be increasing. Now take a look at all of the questions that we covered on this page because it was a lot. This is a lot of information all in one. So please make sure that right now you ask me any questions you have. This is your chance before the EOC to make sure you understand. Questions going once. Questions going twice. All right, cool. Now let's do one. This time I want you guys to try this one on your own. It might be similar, it might be a little different in some places, but take about 2 to 3 minutes. I'll give you guys 3 minutes to just take a moment and see how many you can answer from this example. So 3 minutes going on the clock. Go ahead. Oh, let me go back really quick. Take a picture of this page if you haven't done so yet. All right, cool. Okay, go ahead. 3 minutes. Okay, about halfway through, minute and a half remaining. All righty. So a little bit tougher, this question, I would say, because this graph is a little bit different. I actually want to go backwards, so I'm going to start from the bottom and go up to the top because I think domain and range are going to be a little bit more tricky to answer. But let's take a look. So starting with E, for which values of x is f of x equal to 1.5? So 1.5, input or output? Good, that's my output. And let's see. So when my output is 1.5, that's over here, what is the X value at that spot right there? Good, this is 0, comma 1.5. So X equals 1.5. However, is that the only input value that gives me 1.5? Oh wait, I should have written X equals 0, my bad. X equals 0. Is that the only place where I'm at the 1.5? Ajara says no. So what's the other place? Good, there's one more. Take a look. 4, comma 1.5. So there's two X values, X equals 0 and X equals 4. When f of X is equal to 1.5, when the output is 1.5, there's two possibilities, X equals 0 and X equals 4. So questions on that one? See, that was already one tricky part of this problem. Are there any questions on that? Okay. Now these should be a little more easy. What is f of 1? F of 1. Okay, there we go. Not 1, but 0. When the input is 1, the output is 0, 1 comma 0. What is f of 5? Four. 5, you look up, 5 comma 4. So f of 5 equals 4. Make sure that you understand. If you do not at this point understand how I did C, D, or E, please let me know in the chat. Okay. Now for A and B, a little bit more challenging. I'm going to start with range. The range is all the possible outputs. So let's think about this. You always want to think, what is the lowest you can go? And what is the highest you can go? So starting with lowest, what is the lowest that this graph goes? What is the lowest that this graph goes on the y-axis? Think about height. So you have the x value, Ijara, it is at the x equals 2, but I'm talking about y values. What is the lowest that this graph goes? It doesn't quite make it to the -1. So look again. A decimal. Now let's estimate it as best as we can. Zero 0.2, 0.3. It's somewhere between 0 and -1. So is it closer to 0 or is it closer to -1? Okay, so give us a good number, maybe negative what? Negative, oops. I don't know, I wouldn't go, I think 0.8 would be even closer, even further down. Yeah, negative 0.5 is a good guess. So the lowest that this goes is, well, this is 2 comma negative 0.5. That's the lowest. Now, what's the highest that this graph goes? Good, Ajira, infinity. Guess what? This graph goes up, 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 up. Does it stop here? Nope, it keeps going up, 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 up forever. Same thing on this side. It's going up, 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 and it's never going to stop. So the highest would be infinity. And now I can write my inequality. So the range would be negative 0.5 is less than y is less than infinity. You always go from the lowest to the highest. So again, this one was tricky, but think about it. See if you have any questions on this one, on B. And if it helps you on a question like this, it might be helpful to do it the way I did it. Think, what is the lowest possible number? What is the highest possible number? And that will become your inequality. Any questions at all on B? It's your time, your responsibility to make sure you understand. Okay. All right. Now, domain, similar. All the possible input values. Okay, so now I'm looking at the x values. What is the lowest possible x value? Right, it's not -2 because it keeps going. Here's -1, but the graph isn't stopping there. It keeps going, right? It keeps going and going and going and going and going and going. So even though this is where it ends on this part of the graph, these arrows tell me that it keeps going in that direction. So Ijara, you're correct. This goes to -infinity. And on the other side, what happens? On the other side, it goes to positive infinity because it never stops. It has a minimum on the y value, right? Like it's never going to go lower than -0.5, but that's when I'm talking about y values. If I'm talking about x values, it never stops. It goes all the way from -infinity to positive infinity. So lowest is -infinity, highest is positive infinity. So -infinity, is less than x is less than positive infinity. Or you might see this as just all real numbers. Because there's no limits. There's no limits, so it's all real numbers. Whereas this one would be all real numbers from or it would be all real numbers greater than -0.5. Yeah, Ijara, we did talk about this all the way back in topic 2, but it's been a really long time. So how do you know when to put x and when to put y? It all depends. Domain is input values and input values are x values. Range is output values and output values are y values. So domain is x and range is y. Any other questions on domain and range? Okay. So in that case, we're kind of done with what functions are and how to identify different parts of a function. Now, let's do a couple of word problems. So in this problem, we're still talking about domain and range, but we no longer have a graph. So we're going to talk about how to figure this out when you don't have a graph. So here we go. Aaron wrote the function f of x equals 25x minus 15. To find the amount of money he would make after washing x cars. Select all of the values below that are in the domain of Aaron's function. So this used to be a multiple choice question, but I turned it into not a multiple choice question. So what I actually want to do is not only the domain, but I also want to figure out what is the range. So we're going to talk about both. But the most important thing is that we have an equation. And this is a real world problem, so the equation actually means something. Now, let me read it again. Aaron wrote the function f of x equals 25x minus 15 to find the amount of money he would be making after washing x cars. So guess what? It tells us what the x's represent. Now, is x input or is x the output? Input, good. So what we want to do is we always want to start off by writing down what the input and the output represent. Input would be the number of cars. And now output, they don't necessarily say it as obviously, but read it again. What else is this function talking about? Number of cars and money, yeah. So X is how many cars he washes. And after he washes a car, what does he get? He gets money. So my output is money. Money earned. After you figure out what the input represents and what the output represents, you can think about what are numbers that you can have and what are numbers that you can't have. So let's talk about domain. Domain would be my x values. So what types of numbers are allowed and what types of numbers would not make any sense, considering this is real world. So negatives. Can I have negatives? No. Okay, what else? Decimals. Can I have decimals? No decimals. No fractions either. So what are the only types of numbers that do make sense? Positive. Careful, because real numbers, Karina, real numbers are any type of number. So be more specific. What's the only type? We have positive, what? Whole numbers. The only thing that's allowed, positive whole numbers. So the domain, if I was going to answer this on a test, for example, hopefully it would be multiple choice. Probably it would be multiple choice. So the domain is whole numbers. Another way you might see this, now be careful, Ujira, because integers can be negative. Okay, so this would be whole numbers, or you can also see positive integers. As long as it has the word positive, you're good. But if it only said integers, then that would be wrong because integers can also be negative. So make sure that you read it carefully, positive integers, which means the same thing as whole numbers. Now, one last way that you might see this is as a list. So it might list out the possibilities. You can have 0 cars, 1 car, 2 cars, 3 cars, 4 cars, ... means go on from there. So that's basically the only possibilities if this was a multiple choice question. Questions on the domain. Cool. Now for range, we're going to do things a little bit differently. Now that we know what the domain is and we have an equation, we can actually figure out the range, because the range is the output values. So now let's think about what happens if you have 0 cars. How much money will you make? If he doesn't wash any cars, make $0. What if he washes 1 car? Use the equation now. Plug in a 1. Careful though, it's minus 15. So plug it in, you get 25 minus 15, $10. What if we wash 2 cars? Plug it in, 50 minus 15. $35. Let's just do one more, 3 cars. Plug in a 3, 25 times 3 is 75. 75 minus 15, you get 60. And so on. So the pattern goes 0, because if you don't wash any, you don't get any. And then 10, 35, 60, and so on. So the range would be 0, 10, 35, 60, ... Because the range is not going to be all positive numbers. It depends on how many cars you wash. So it follows a very specific pattern because it depends how many cars you wash is going to tell you how much money you earn. Domain and range in a word problem, definitely a little tricky. Does anyone have any questions? It looks like standard form. So this is actually not standard form though, because what type of function is this? We'll talk about this more on Wednesday. There's no exponent. So this is not a quadratic function. This would be anyone? Y equals mx plus b. What would that be? What type of function? Please, someone out there, remember this. It has slope. It is slope-intercept form, which means it's a what kind of function? Linear function. Good. This is linear. We'll talk more about that tomorrow or on Wednesday. Okay, I think that's it for domain and range. Good, we're doing perfectly on time. So the last thing I wanted to cover today was average rate of change. And we did this in the bell ringer, but we're going to do it a few more times now. Rate of change formula definitely goes on the list of things you got to remember. So let me write it down. Y2 minus Y1 over X2 minus X1. It's not too bad. but it has been a while. So just make sure that that's something you have it in your notebook. And by the end of next week, we're going to make a big list of everything that you have to have memorized. It's not even that big of a list, to be honest, but this will definitely be on that list. So here we go. The value of an antique has increased exponentially as shown in the graph below. Based on the graph, estimate the average rate of change in value of the antique from 0 to 40 years. So they're always going to tell you the interval. And you just have to go look on your graph to see what that interval would actually be. So 0, comma what? Good, 0, comma 1000. And then 40, comma what? $5,000, good. Okay, I have 2 points, and there's always 2 ways to do this. You can do the formula, or you can do rise over run. But if you do rise over run, you have to be careful because you're not just going to count the boxes, you're going to count the value of each box. So that's why I prefer to do the formula, because if you do the formula, you are always going to get the right answer, as long as you fill it in the right place. So what would be my Y2? Y2, the Y value of the second point. $5,000, good. So I have 5,000 minus, what's Y1? 1,000. What's X2? 40. And X1, 0. So Y2, Y1, X2, X1. And that's just because this is my second point and this is my first point. So I have X1 and X2 and Y2. I have X1 and Y1. Do I have any questions on where those numbers come from? Cool. And then you just do a little bit of math. So 5,000 minus 1,000, that's 4,000. 40 minus 0 is 40. And what would be 4,000 divided by 40? Good. 100. Now, we always want to do units. So this would be 100 what? We have years. So think about what was on top. This was 5,000 and 1,000 what? Dollars. So $4,000, and this was 40 and 0 years. So my final answer would be $100 per year. $100 per, the line is per. So it's numerator per denominator, dollars per year. And this is something that I've seen come up on the EOC every single year. So you can bet that you're going to have a question like this. And that's a sure bet. So please make sure that you understand how to do it and ask me any questions at this time. All right. No questions? Okay. Next up, we could have the same situation, but this time on a table. So let's take a look at this one. Rachel and Mark were given the information shown below about the bacteria growing in a petri dish in their biology class. Find the average rate of change for the following intervals. So we're just finding it from 1 hour to 4 hours. Now you're going to do the same exact thing. It's just that we have a table instead of a graph. or I'm still going to go to the 1 hour mark and then the 4 hour mark. Now these 2 points would be 1, 220 and 4, 440. This is the X value and this is the Y value. So now I can go ahead and I can use my formula. And remember what I said before, if you're doing a problem like this, always start by writing the formula down, because when you write it down, you're going to be much more capable of memorizing it. So even if you already have it memorized, get into the habit of always writing it down. You don't want to rush this. What would be my Y2? 440, Y1? $220. X2, 4, X1, 1, and we do the math. 440 minus 220 is 220. Now let's do the units real quick. This would be 220 what? Bacteria, good. 4 minus 1, I get 3, and then that would be 3 what? Good, hours. So my final answer, once I divide 220 divided by 3, what do I get? It's about 74, yeah. I would leave it as a decimal for now, but you might see it as a multiple choice or fill in the blanks. You always want to read carefully as to what it says. So let's just say round to the nearest 10th for this one. So 73.3 bacteria per hour. So rate of change on a graph, rate of change on a table. Take a moment, make sure that you've written everything down, and let me know if you have any questions. I believe we have one more question to go. So finally, we're going to find the average rate of change, but this time I don't have a table, I don't have a graph. All I have is this function. But don't worry, we'll still be able to figure it out. The function f of t equals negative 16t squared plus 20t plus 4 gives the height of a ball in feet, t seconds after it is tossed. What is the average rate of change in feet per second over the interval 0.75, 1.25? So this is an interval right here. This is not a coordinate point. This is just telling me that I'm going to go from 0.75 and specifically, remember, intervals are x values. So from x equals 0.75 to x equals 1.25. So my interval is telling me that I'm going from 0.75 to 1.25. But that's just the x values. Do I know the y values? Because remember, I'm going to need to plug them in. Do I know the y values yet? Read the problem. Does it tell you the y values? Well, that's the y-intercept, but that's not the corresponding y values. So here's the problem, is if I would make this into a table, I know that I'm 0.75 comma something and 1.25 comma something. But I don't know what those values are. However, I have a function equation, so what can I do with the numbers 0.75 and 1.25? Good, Ijara. We are plugging those in. That is exactly what we're doing. So starting with 0.75. And as you can probably guess, calculators are allowed. Here we go. Quickly now, because my time's running out. 0.75 to the power of 2. I get I get 0.5625. Oops, 25. Don't just guess. Make sure you actually plug it in. 0.75 times itself. Then I'm just bringing everything else down. Oh, I see. You skipped. Okay. Then we multiply. 0.5625 times negative 16 is negative 9. 20 times 0.75 is 15. And then plus 4. Negative 9 plus 15 plus 4. Careful, negative 9 plus 15. There you go. We end up with 10. Negative 9 plus 15 gives me 6, and then 6 plus 4, I get 10. So my y value would be 10. F of 0.75 equals 10. Now I got to do the same thing, but this time I'm plugging in 1.25. So I am going a little fast. That's because I just want to make sure we finish this problem. But we'll see a similar problem tomorrow, so don't worry if you feel a little rushed. Okay. Now I'm plugging in 1.25 and doing the same thing. Here we go. 1.25 times itself. I get 1.5625. 1.5625 times negative 16. I get negative 25. 20 times 1.25 gives me positive 25. And now negative 25 plus 25 gives me 0, and then 0 plus 4, I got 4. So my output is 4. And now I have completed my table. And now that my table is complete, remember, don't lose sight of what we're doing. We're finding the average rate of change. So I go back to my formula and I plug everything in. So this would be 4 minus 10 over 1.25 minus 0.75. It goes down, yeah. 4 minus 10 is negative 6. 1.25 minus 0.75 is 0.5. And then we, again, using our calculator, negative 6 divided by 0.5, what do I get? Negative 6 divided by 0.5. negative 12. So my average rate of change would be negative 12 feet per second. So, okay, yes, we did that pretty quickly. If you feel like we rushed through it and you got lost, I'll try my best to make sure we do it a similar question tomorrow so that we can make sure that you understand how to do it. But are there any quick questions on this problem? Okay, those of you who were testing, since you missed today's review, highly, highly, highly recommend that you watch it later on YouTube. But tomorrow we'll basically be reviewing the same stuff. So if you watch the YouTube tonight, you'll have a chance to practice it again tomorrow. Lastly, homework policies changing a little bit for this last month. So this is the most important thing. Make sure you take a picture of the screen. For the next month, your homework will be found on Teams, not Khan Academy. It's going to be on Teams, and it's going to be under your algebra period. So some of you guys are period 1, some of you guys are period 7. It's always going to be in your algebra period, not in your research period. Homework assignments are always going to have 10 questions that cover everything that we talked about this week. So we're going to have functions. What is a function? What's not a function? Parts of a function, domain and range. Everything that we're going to talk about this week will be on your homework assignment. Homework assignments will be due Friday at midnight. That doesn't really change. That's always been that way. If you plan to complete your homework in sections, so let's say you want to do 2 questions tonight, 2 questions tomorrow night, and do it little by little, just make sure that you save your answers on a separate sheet of paper. Because if you start the assignment and then X out of it, I don't know if it always saves your work. So just make sure that you have it written down somewhere else. And that way, when you go back to it, you can put what you had. Finally, your grades will count for both algebra and research. So even though it's only 1 assignment each week, it counts for both classes. So if you get a C on it, you're getting a C in algebra and you're getting a C in research. Questions on that? I see a question in the chat. Why are we not using Khan Academy? Because now that we're in review mode, I want to make sure that you're seeing test questions always. So your homework is going to have questions that are a little more like the test, whereas Khan Academy does things a little bit more differently. So I want to make sure that everything you see is the way that you would see it on a test. That's why. Yeah, no more Khan. Basically, we're done with Khan. Any other questions on the homework policy? Okay, as a reminder, it is due Friday at midnight, but you're always welcome to get it done beforehand. So at this time, I'm going to upload it right now to your period 1 class. And Sophie, I'll upload it to period 7 later today after I see my 8th period, but it'll be up and you can get started on it as soon as you want. Any final questions for today? The grading, since it's out of 10, the grading is going to be similar to your test that you took on Friday. So I'll include the grading scale in the description so that you can see what it is. Okay. All right, cool guys. Have a lovely day. I will see you all tomorrow. Bye everybody.